Hello everyone. On this video we will be going over solid figures, in particular right prisms. Okay. Now I tried drawing the prisms myself, but after failing time and time again to make them look anything like they're supposed to, I just decided to go ahead and go on the internet and print up images of what they look like. And I am not ashamed to admit that my attempt at drawing them will never see the light of day because they were horrible. Alright, so starting off, a prism is just a three-dimensional solid object where the two ends that we call your bases are equal and the lateral cross sections are also equal. Okay, so on this image here, which is a hexagonal prism, you have the two bases that are parallel. Okay, so these are the two surfaces that are parallel. Okay, which means this side goes the same direction as this side goes the same direction as this side, they're all parallel. Okay, so these two bases are equal. They have the same area, they have the same perimeter, they have the same everything. Also, these two lateral cross sections, which is this side and this side, on this image, they're also equal because they're parallel. All right. Now your altitude is the distance between your two bases. Okay. Now I didn't want to write, this is the same image, I just didn't want to write a whole bunch of stuff around this one. Now your edges, let me slide this up a little bit more. Now your edges are literally just the lines of your image, whatever the image may be. Now your altitude is just the distance from one base to the other. Okay, so if you have two bases, which you should if you're talking about a prism, the distance between that base and the other base is your altitude. And your vertices are just the corners located all over your particular shape. Okay, well, I'm going to roll it back up, just rolling it down for a second. Okay, so this is your altitude here, the distance between your bases. Okay, so even if you can't draw these yourself, you may want to go online and print up an image of them, but you can write those down. All right, so if you're still writing, feel free to press pause and finish those up. But we're going to go ahead and move on to our next page. And again, I got these images from the internet because I could not draw them. Okay, now a right prism has edges that are perpendicular to the bases. Okay, so in other words, if this is your base here, and this is your base here, you have your right angles. Okay, now if you have an oblique rectangular triangle, these are not right. You see this angle here is not right. It's kind of slanted. Okay, so it's not a perfectly right angle. Here, if you notice here, if you have your base up here and your triangular base down here, you have your right angle connecting your base and your lateral sides. You have your right angle here connecting your base and your lateral sides. Okay, so your base and your lateral sides are all connected by a right angle. You see here, this one is not right. So that's why it's not a right triangle. Now everything we're going to do is going to revolve around the right prisms. Okay, so all of these formulas will work on right prisms. All right. So if you are still writing, of course, feel free to press pause. We're going to go ahead and move on to our next page, which basically shows you different types of prisms. These are not all of them, not by a long shot. You have a lot of different types of prisms, but these are just 4 of the basics. Okay, so you have your rectangular prism. Okay, so you have your 2 parallel bases. So we have, this is our base and this is our base, and our altitude is the distance between those bases. Okay, that's going to be the same for each and every prism. That's not going to change. The only thing that changes is the base. In this case, the base is a rectangle. In this case, the base is a triangle. It's a triangular prism because the base is a triangle. Well, the bases are triangles. So you have your base, and the distance between your bases, is your altitude. Okay. Same thing here, where you have a cube prism. Okay, this is the best image I could find that actually looked like a cube. Okay, so again, you have your base, and your altitude is the distance between those bases. Now with rectangular and cube prisms, the base can actually change. Because remember, the base is just the parallel sides that are across from each other. So if you have let me scoot this down a little bit. If you have a rectangle, this could be your base and this could be your base because they're parallel to each other. Okay, same with a cube. You can pick 2 parallel sides and make them your bases. And then your altitude is just the distance between those parallel sides. So this is not always going to be your base. Sometimes your base are the 2 sides here. Sometimes the bases are the front and backs. You'll still use the same approach. Okay, and the 4th one we're going to look at is your trapezoidal prism, where you have your base is a trapezoid, and then if you look at it from the back, this side will be your base, will be your trapezoid, and your altitude is just the distance between those 2 bases. I've tried to draw it sideways, but I couldn't. So the distance between those 2 bases is your altitude. All right, so probably the better way to draw this would be at a little bit of an angle. So we'll say your altitude should be this way. Okay. Now, we don't know exactly what that is, but we know that the altitude is the distance between those 2 bases. All right. So if you are still writing, feel free to press pause. And again, if you want to have these images, you can probably print up a copy online just to, and unless you're good at drawing. So if you're better at drawing than I am, feel free to draw them. Okay, now these are the important things that you're going to know about what we're working on with prisms in this video. All right, so we're going to let h represent the altitude, which is the distance between the bases that I showed you. P is just the perimeter of the base. Remember, to find the perimeter of the base, you just add all the sides together. And you have the area of the base. Now, the area of the base depends on what shape the base is. If the base is a rectangle, then your area will be base times height. If your base is a triangle, then your area will be 1/2 times the base times the height. Okay, so it kind of changes. So this is really fluid. This changes depending on that particular shape. So we're going to go over examples as to how that's going to look. Okay, so you have your right prisms. We're going to find what we call the lateral surface area, which is all of the sides. Okay, so to find your lateral surface area, you're going to multiply your perimeter of the base times the altitude. Okay, remember the altitude is just the distance between the bases. Your total surface area is everything. That's the area along the sides, the area on the top and the bottom. That's everything, to find out exactly how much surface area you have over that entire shape. Okay, so to find your total surface area, you're going to find your lateral surface area then you're going to add 2 times the area of the base. And then to find the volume of that particular shape, you're going to get the area of the base times the altitude. Okay. Now you can use this for all shapes, all of your prisms. But just for the cubes, if you wanted to, you could still use this for the cubes. So you don't have to change anything. This is just a little extra information if you want it. Okay, so just for cubes, if you want to find the lateral surface area, and let's say S is the length of your side, remember for a cube, all the sides are equal. They all have the same length. Left, right, up, down, back, forward, all the sides have the same length. Okay, so to find your lateral surface area, you just get the side squared and multiply it by 4. To find your total surface area, you get the side, you square it, and then multiply it by 6. And to get the volume, you get the sides, and you raise it to the 3rd power. Alright, remember that's just for cubes. This will not work for any other prism. This is just for the cubes. Alright, now little extra tidbit in case you run across something and it looks a little confusing. Sometimes the total surface area will be denoted by an uppercase S. So instead of T equals L plus 2A, you may see S equals L plus 2A. It's the exact same thing. They just chose to use S right here instead of T. The formula is exactly the same. Nothing changes. Okay, same thing here. Okay, sometimes you may see S equals L plus 2A, and sometimes you may see T equals L plus 2A. Exact same thing. It all depends on the question, the textbook, who wrote the book, what they decided to use. It's the exact same thing. All right, so I don't want you to get confused if you happen to see S equals L plus 2A somewhere, and they're asking for total surface area, or you see T equals L plus 2A. Same thing. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and jump to our first example. Okay, so what if we wanted to find the lateral surface area, the total surface area, and the volume for this following prism? And we want to round our answer to the nearest whole number. All right, so first thing you always do when you're looking for surface area, total surface area, or volume is you want to find your altitude, okay, you want to find the perimeter of the base, and you want to find your area of the base. Okay, so this can get a little bit tricky, and I'll show you why in a second. But this can get a little tricky, but I'm going to walk you through it, so you have to pay pretty close attention, because like I said, you can get slipped up a little bit. Okay, now for our altitude, our h is the distance between our bases. So if this is our base and this is our base, then the distance between those two bases is 4.5. So it's 4.5 inches. I'll just write that instead of actual inches. Okay. Now, to find the perimeter of our base, remember to find the perimeter, you pick either base and you add all the sides. So if this is 3 inches, then this side will be 3 inches. If this side is 2 inches, then this side will be 2 inches. Okay, so that's 3 inches plus 2 inches plus 3 inches plus 2 inches. Okay, so we know that our perimeter is going to equal 3 plus 2, which is 5, 8, so that would be 10 inches. Okay, so we have our perimeter, we have our altitude, we just need the area of the base. Okay, so now This is where it can get tricky. Okay. Now, I always recommend drawing a little miniature diagram of your base. Okay, so you see here, our base is a rectangle. Okay, so we have our rectangle here. It doesn't have to be perfect, just a little quick sketch. Okay, one side is 3 inches, and one side is 2 inches. So we know the area of a rectangle is 1/2 the base. I mean, not 1/2 base times height, that's the triangle. Is base times height. Area equals base times height. Okay. Now, this is the confusing part. You want to separate this. So I always draw like a little box around it. Because the height of your rectangle is not the same as the altitude of your prism. So these two H's are different values most of the time. The H's are different. Okay, so you do not want to say, okay, the area of this base is the base times the height, because it's not the H that we're using for this. This is just the H that we're using for this rectangular base. So we know that our area is going to equal 2 inches times 3 inches, which is 6 inches squared, or 6 square inches. Okay, so we know that our area is 6 square inches. Okay, so now that we're done with this, everything else we do will use this H. Okay, so when we find the surface area, the lateral surface area, and the volume, we're going to use this H. We only use a different H when we're looking for the area of the base. All right, so now we can go ahead and jump to everything else. So you have our lateral surface area. Okay, so we know our lateral surface area is L is equal to the perimeter of the base times the altitude. Okay, now remember, now we go back to using this H. We only change the H to find our area of the base. Everything else we do from here on out involves this H, our altitude. Okay, so that's going to equal 10 inches, because that's our perimeter of the base, times 4.5 inches, which is our altitude. So 4.5 is just 4.5. Okay, so we know that it's going to be 45 square inches. For our lateral surface area. Okay, now if we're looking for our total surface area, we just use that formula. Okay, so our total surface area, T is equal to L plus 2A. Okay, so our lateral surface area, we know that's 45 square inches plus 2 times the area of the base, which is 6 inches squared. Well, 6 square inches. Okay, so that's going to equal 45 square inches plus 2 times 6 is 12, plus 12 square inches, which is 57 square inches. Okay, so we kind of separate these a little bit so there's no confusion. All right, so now we look at our volume. Okay, so the volume is the area of the base times our altitude. All right, so that's going to equal the area of the base. Remember, that is 6 square inches times our altitude, which is 4.5 square inches, or 4.5 square inches. Okay, so that's going to equal 27. Oh, actually, this should be 4.5 inches, not square inches. Sorry about that. Okay, so this should be 27, because 4 times 6.5 is 27. And inches squared times inches is inches to the 3rd power, or inches cubed. So it would be 27 cubic inches, or 27 cubic inches. Either way you want to write it. All right, so again, when you get the area of the base, do not confuse your altitude with the height. That's why I always draw a little picture of the base, whether the base is a triangle, whether the base is a rectangle, whether it's a square, whether it's a trapezoid, doesn't matter. I always draw a little picture of the base so I know not to mess that up and do that. All right, so if you are still writing, feel free to press pause and finish up. But we're going to go ahead and move on to our next example. Okay. Now for this one, I want you to look at it. And I want you to find the lateral surface area, the total surface area, and the volume for this prism, and round to the nearest whole number. All right, now just to give you a little bit of a hint, this base is a trapezoid. All right, now 99% of the time, they're not going to tell you the base is a trapezoid. You have to kind of look at it. But you can tell because you have 2 parallel lines of a quadrilateral, and the other 2 lines are not parallel. So when you have 2 parallel lines, which are these 2, and 2 lines that are not parallel, and you have 4 connecting sides, it's a trapezoid. All right, so go ahead and press pause, and I want you to try this one on your own. All right, so I'm assuming you've pressed pause and already worked it out. So let's go ahead and verify. Okay, remember your first step. Okay, you want to find the altitude, the perimeter of the base, and the area of the base. That's why I shaded this part in, because that's your base. And again, a lot of times they won't shade it in. You'll just have to be able to look at it and tell, okay, well, these 2 sides are parallel, so those must be our bases. Always think of it this way. If you can slice right between the 2 bases and it has the same shape, then you know that's the base. So you notice here, you can slice between those 2 sides. So right between there, if you slice it right down the middle with a saw that's parallel to the bases, it'll have basically the same shape. All right, so let's go ahead and get started. Okay, so our altitude, which is h, is the distance between our bases. So if this is our base here, and our base here is on this side, the distance between those 2, we can look here and tell that goes from base to base. So the distance between our bases is 18 feet. Okay, so we have our h. What about the perimeter of our bases? Okay, so the perimeter of our base, we look here, we see this side is 18, 16, 6, and 20. Okay, so 6 feet plus 16 feet plus 20 feet plus 18 feet. We add all those together, our perimeter equals 60 feet. All right, so we have those 2 out the way. Now we have to find the area of our base. again, when you're looking for the area of the base, I do recommend making a little sectioned off area because you do not want to confuse your H's. Okay, now we have our trapezoid. We have the area of a trapezoid. Okay, so I have 6, 18. Like I said, it doesn't have to be perfect. Okay, so we have our base 1, our base 2, and the distance between our bases here is our height. Okay, so we know that the area of a trapezoid is base 1 plus base 2 divided by 2. Thinking ahead too far, times our height. Okay, so that's going to equal our base 1, which is 18, and base 2, which is 6, or 18 and 6, doesn't matter which one you put as base 1 and base 2. So you have 18 feet plus 6 feet divided by 2 times the distance between those two bases, which is 16. Okay, so this is going to be 8 plus 16, which is 24. So you have 24 over 2, which is 12 feet times 16 feet, which comes up to 192 square feet. All right, now we go back to everything else. Once we find the area of our base, we go back to using this H. Okay, we're not even looking at this H anymore. Everything we do from here on out is this H. All right, so we're going to look for our lateral surface area. Okay, and that is L equal the perimeter of your base times the altitude. Okay, so that's going to be the perimeter of the base is 60 feet. And your altitude is 18 feet. That doesn't matter how you put it, that's feet and that's feet. So that comes up to be 1,080 square feet. Okay, so let me go ahead and separate that a little. Now we look for our total surface area. And that's T is equal to our lateral surface area plus 2 times the area of our base. Okay, so that's going to be our lateral surface area, 1,080 square feet, plus 2 times the area of our, there we go, so we have 2 times 192, area of our base, 192 square feet. Okay, so we go ahead 2 times 192, that gives us 1,080 square feet, plus 384 square feet. Okay, so we add 1,080 and 384. That gives us 1,464 square feet for our total surface area. So if we get the area of this side, the back, the bottom, and the two bases, that's how many square feet of, oh, I thought you could see that. What I was saying was if you get the area of this side, the bottom, that side, and the other side, that surface area will be 1,464 square feet worth of space. There we go. And now we find our volume. Okay, so remember your volume is equal to the area of the base times the altitude. Okay, so the area of the base is 192 square feet times the altitude, which is 18 square feet. So that means our volume would be 3,456 square feet. Okay, so hopefully you're starting to kind of get the idea. All right, so if you're still writing, by all means, feel free to press pause. But we're going to go ahead and move on to our next example. Okay, you want to find the lateral surface area, total surface area, and the volume for the following prism. Round your answer to the nearest whole number. Okay, so what I want you to do is go ahead and press pause and try to solve this one on your own. Oh, in case you can't see it, just to clear it up, this is 12 feet, this is 9 feet, this is 6 3/4 feet, and the height of this triangle, I've tried to draw it here, let me kind of clarify, the height of this triangle is 5 feet, and this is 15 feet. Okay, so now if you want to press pause and try it on your own, now that you kind of get an idea of what the numerical values are, you can. All right, so I'm assuming if you press pause and worked it out, you're okay. So let's go ahead and verify your answer. Okay, as always, your first step to find your altitude, perimeter of your base, and the area of your base. Okay, so we know that our altitude is the distance between the bases. So this is our base and this is our base. The distance between those two bases is 15 feet. Oops. Let me clean that up because that means inches and 15 feet. Okay, so we have our altitude. The perimeter of our base. So if this is our base here, we know it's 12 plus 9 plus 6 3/4. 12 feet plus 9 feet plus 6 3/4 feet. We know that our perimeter is going to equal 27 3/4 feet. Okay, so that's the perimeter of your base. Now, once again, whenever you're calculating the area of your base, I do recommend you draw a little box because it's going to be really easy to mess up and you don't want to mess up. Okay, area of the base. Okay, so we know the area of the base, our base is triangular. This is triangle, this is triangle. So we go ahead and draw a little triangle. Like I said, it doesn't have to be perfect, just something to help you visualize. And we see here that the height of that triangle is 5 inches. And the base, which is right here, is 12 inches. We know it's the base because it goes down right here. You have your right angle, and it's at the bottom. So that's our 12 inches. Okay, so we know the area of a triangle is 1/2 the base times the height. Okay, so that's going to be 1/2. If you want, you can make 1/2 0.5. It's up to you. 1/2 the base, which is 12, times the height, which is 5. Okay, so 12 times 5 is 60. So you have 1/2 times 60, 60 feet, 5 feet, 60 square feet. 60 square feet times 1/2 is 30 square feet. Okay, so our area is equal to 30 square feet. So now that we have that, remember, as soon as we're done finding the area of the base, we go back to using this H. Okay, so that means we have our lateral surface area. Okay, so we know that that is L is equal to the perimeter of the base times the altitude. Okay, now the perimeter of the base, we know that that is 27 3/4 feet times the altitude, which is 15 feet. Now 3/4, we know that's 0.75, so we can make that 27.75 feet times 15 feet. Plug that into your calculator, you get 416.25 square feet. But we want this rounded. Remember, we want to round it to the nearest whole number. So this will be rounded to 416 square feet for our lateral surface area. All right, so now what about our total surface area? Oh, sorry about that. Thought I had it up far enough. Here we go. Okay, so for our total surface area, remember that formula. The total surface area equals our lateral surface area plus the area of our two bases. Okay, so we know that our lateral surface area, we're not going to use the rounded, we're going to use the actual surface area. So 416.25 square feet. Can't forget our unit of measure, plus 2 times the area of the base, so 2 times 30 square feet. Okay, 2 times 30 is 60, so this becomes 416.25 square feet plus 60 square feet. Okay, so that will become 476.25 square feet. But if we round it to the nearest whole number, you have 476 square feet. Okay, so that's our total surface area. Now we look at the volume. So let me separate that. Now our volume equals the area of the base times the altitude. Okay, so the area of the base, we know that's 30 square feet. Times the altitude, we know that is 15 feet. Okay, so 30 times 15 is 450. And square feet and feet is cube feet or cubic feet. And that is our volume. All right, so not too bad. All right, so if you're still writing, of course, feel free to press pause. But we're going to go ahead and move on to our next example. Just want to make sure you got it. Okay, for this example, of course, I want you to try it. But find the lateral surface area, the total surface area, and volume for the following prism. We want to round to the nearest whole number. Now for this one, every side is 7 centimeters. So whenever every side is the same length, you automatically know it's a cube. All right, so go ahead and press pause, and I want you to try this one on your own. All Alright, so I'm assuming you've pressed pause and you have worked it out. So let's go ahead and verify your answer. Okay, so we know for this one, of course, first thing you want to do is find your altitude, perimeter of the base, and the area of the base. Okay, so we know that our altitude, it doesn't matter which side we make the base, which side we make the altitude, all of these are the same. So if we make this top base, the base, and the bottom the base, then our altitude is going to be the distance between those two, which is going to be 7. So our altitude, h equals 7 centimeters. And our perimeter of the base, you can find any side. Again, it's a cube. All the sides are equal. So if you want to pick the base right here, this would be 7 plus 7 plus 7 plus 7 because you're adding all the sides of your base. Okay, so 7 centimeters plus 7 centimeters plus 7 centimeters plus 7 centimeters. Okay, so we know that our perimeter of our base is equal to 28 centimeters. Had a little bit of a brain freeze there. Okay, now we find the area of our base, and again, I do recommend always doing this. Area of our base, which in this case is a square, or you can use rectangle, it would be the same thing. And so 7, 7, 7, and 7. Okay, so because it's a square and all the sides are equal, you can use area equals base times height, or the area is equal to that side squared. Because base times height is 7 times 7, and that side squared is just any side squared, which is 7 times 7. Okay, so either one, you have the area equals 7 centimeters times 7 centimeters, which is 49 centimeters squared. Okay, so we have our area of the base. All right, so now once again, we go right into our lateral surface area. Is L is equal to the perimeter of the base times the altitude. Okay, so this is going to be, the perimeter of the base is 28 centimeters times the altitude, which is 7 centimeters. That means our lateral surface area is going to be 196 squared centimeters. Now remember, at the very beginning, I showed you the formula that you can use for cubes only. Okay, you can't use this other formula for any other. So you can say, or our lateral surface area is equal to 4 times the side squared. Okay, the side squared is just 7. So that's 4 times 7 centimeters squared, or just 4 times 49 squared centimeters, which is 196 centimeters squared. So you get the answer either way. So remember, this side for cubes only. Now, I don't want you trying to use this one for any other type of prism. It only works for cubes. So if you try and use it for the rectangular prism or for the triangular prism or for the any other type of prism, I don't want you to say, but you said it would work. And no, I didn't. I told you this one right here only works for cubes. But you said on your video that no, I did not. This right here only works for cubes. But I thought you meant, no, you didn't. This right here only works for cubes. I want you to remember that. All right, so let's go ahead and move on to the next one. So our total surface area. Remember, our total surface area is equal to L plus 2 times the area of the base. Okay, we already know our lateral surface area is 196 centimeters. Well, squared centimeters. Plus 2 times the area of the base, so 2 times 49 squared centimeters. 2 times 49 is 98. So this is going to equal 196 squared centimeters times 98 square centimeters, which is 294 squared centimeters. Or, remember, for cubes only, oh, that's not the L, T. T is equal to 6 times the length of the side squared. Okay, so that means it can equal 6, make sure I draw that separating, times 7 squared. Okay, or 6 times 7 is 49. So 6 times, I messed up a little bit there. I meant to put the square on the outside. So S squared is 7 centimeters squared. Need to slow down. So you have 49 centimeters squared. 6 times 49 is 294 centimeters squared. There we go. Sometimes I get a little bit ahead of myself and start moving too fast. So I just have to slow down. All right, so let's move on up because we still have to find our volume. Okay, so let's go ahead and separate that. So we have our volume, which is equal to the area times the altitude, the area of the base times the altitude. Okay, which is equal to the area of the base. We know that's 49 squared centimeters times the altitude, which is 7 centimeters. Okay, so 49 times 7 is 343 centimeters squared times centimeters is centimeters cubed. Or you can use the formula for cubes only. That the volume is equal to the length of the side to the third power. Okay, so that means our volume will equal the length of the side, which is 7 centimeters, to the third power. 7 to the third power is 7 times 7 times 7, which is 343 centimeters cubed. Okay, so you can use either one of those approaches for a cube. And again, it will not work for any of your other prisms. It will only work for the cube. And it's just one of those things that if you want to use it, you can. And if not, you can just stick to the very same thing that we've been doing all this time, and you will get the exact same answer. This way you won't have to try and memorize anything new. All right. So if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. There we go. Good old-fashioned story problem. All right, so we want to calculate the volume of water needed to fill this swimming pool in gallons. And you want to round your answer to 3 significant digits. All right, so what I want you to, of course, I had to print out a copy of this image because I could not draw it to save my life. But what I want you to do is go ahead and press pause and try this one on your own. All right, so I'm assuming you've already pressed pause and you've worked this one out. So let's go ahead and verify. Okay, now if you notice here, this side here is a trapezoid. You have your 3 and your 11. Those are parallel, and your other two sides are not parallel. Okay, so this pool is a prism with a trapezoidal base. And clean that up a little bit. There we go. Okay, so it's a prism with a trapezoidal base. Okay, we see here that the distance, well, this distance, because you can see this goes at a downward slant, and this shows you the distance from this base to this base. All right. So we know that 25 yards, we want our answer in feet to match everything else. This is feet, this is feet, this is feet, this is feet. So 25 yards is equal to 75 feet. Okay, so first thing we have to do, we have to find our altitude. But the thing is a little bit different than our other problems because we're only looking for the volume. We're not looking for the lateral area. We're not looking for the total surface area. We're just looking for the volume. And volume is the area of the base times the altitude. So we only need those two things. Okay, so we don't have to solve for all of those things for every problem. We just need the volume because that's all they are asking for. All right, so we know that our altitude is the distance between our bases. So this is our trapezoidal base, and the other side is our trapezoidal base. We know the distance between those two is 12 feet. Okay, so we have that. Now we have to find the area of the base, which is the area of this trapezoid. And I'll do that right over here in the corner. Area of the base, which is a trapezoid. And remember, the area of a trapezoid is equal to base 1 plus base 2 divided by 2 times the height of that trapezoid. Okay, so we know this is base 1, our two parallel sides. This is base number 1 and base number 2. So this is going to be 3 inches, well, 3 feet, plus 11 feet divided by 2 times the distance between those two bases. So the distance is 75 feet. Because remember, our 25 yards is equal to 75 feet. Do not replace this with your h. Remember, that's your altitude. That goes here. Big mistake if you plug this into here and you will get a completely different answer. It will be a wrong answer also. So the distance between those two, the height of that trapezoid is 25 yards or 75 feet. Now, if you put 25 yards in there, it would not be wrong. You just have to convert your final answer, which would make it a whole lot more difficult because you would have to, you can't combine feet and yards until you convert one or the other. So if you did put 25 yards here, you could do this step, which is 3 plus 11 is 14. So 14 divided by 2 is 7. 7 feet times 25 yards. You could do that, but you could not combine those two values until you change them both to feet. So that's why it's better to go ahead and change it to feet up here and not risk messing up. Okay, so you have 7 feet times 75 feet. So it's going to equal 525 square feet. Okay, so that's our area of the base. So now we go ahead and plug everything in here. So our volume is going to equal the area of the base, is 525 square feet, times our altitude, which is 12 feet. Okay, so we know that our volume is going to equal 6,300 cubic feet. Okay, and there's a reason I'm not circling that answer, because it is not our final answer. Okay, we know it's 6,300 cubic feet, but they want to know the answer in gallons. That's why you have to read the question carefully and don't get lost to what you're looking for in the end. We're looking for our answer in gallons. Okay, so we want to convert this to gallons. Okay, convert 6,300 cubic feet to gallons. How do we do that? Well, we know 7.48 gallons equals 1 cubic foot. Okay, so that means our volume, which is 6,300 cubic feet, we write 6,300 cubic feet over 1 times, we're going to go ahead and convert it, 7.48 gallons divided by 1 cubic foot. And these two will go ahead and cancel each other out. So that leaves us with 6,300 times 748 divided by 1 gallons. So 6,300 times 7.48 is 47,124 gallons. Okay. And again, you notice I did not circle that answer yet, because they wanted to round it to 3 significant digits. So our volume will equal approximately 47,100 gallons, rounded to 3 significant digits. Now we can circle our answer, because we're done. All right, so hopefully this made sense, and I will see you on the next video.